for this problem, what you're wanting to look at is your substrate, so your starting material, along with your reagent, and decide, is there more than one functional group that reagent could react with, and is it selective for one over the other, or is there more than one position in the molecule that could be affected, yet the reagent only affects one position. So A, this is an organic 1 reaction, an E2 elimination. And this is a bulky base, sodium tert butoxide. And when we do an elimination, we eliminate across the double bond. And this molecule here actually has hydrogen here next to the bromine, so beta hydrogen. If that's your alpha position, we have beta hydrogen. And then we also have hydrogen here. This particular bulky base does what we call Zaitsev elimination, meaning it's selective for the less substituted side, because it's easier for that bulky base to come into this less substituted side to grab a proton and to do the elimination. So since there's two options where it could eliminate from, but it selects one over the other, this is a selective reaction. B, we have a Grignard reagent. The substrate has two potential reactive sites, the carbonyl and the alpha-beta unsaturation. But the Grignard is selective for the carbonyl. So that's a selective reaction. C, LDA being a base has the potential to deprotonate at either of the alpha carbons, here or here, to form an enolate. What we see in the product is that the new ethyl group was selectively added to this side. So that means this base selectively deprotonated the less substituted carbon, which is what we know LDA does. So C is the selective reaction. D, this is an LEH reduction. We only have one functional group in the molecule, the ketone, and it gets reduced. So there's no selectivity here in choosing a certain site or anything like that. So this is not a selective reaction.